This will be a quick review of the new features found in SkyTrack version 1.7.2, which was just uploaded a couple days ago. First thing you'll notice is a change in the upper left-hand corner here. The local sidereal time is now displayed up in the caption bar alongside the site. And of course, that time is related to your site, being your local time, your time zone, and also the longitude of the site. Beside the tracking indicator, we now have a little more text. I think before that tracking indicator may have been a little confusing with what exactly it meant, whether it was satellite tracking or sidereal rate tracking. So now it'll say, when it's indicating it's tracking, it'll say either off, like it is now. If you're satellite tracking, it'll say satellite. If you're just tracking with the stars, then it's going to say sidereal. And of course, with the new recent feature of JPL custom tracking, if you're doing that, it'll now say custom up there. So this gives you a better indication of what your mount is doing at a glance up in that corner. There's a new icon here, and that is as you click that icon, you'll alternate between 3 different options that are also found under setup, and that is what kind of lines you want to draw. So I have a German equatorial mount, so if I'm slewing around manually or whatever, I prefer these RA deck lines, but otherwise I prefer the Alt-Az lines because it's just easier to see at a glance at what elevation the object is. So this line here would indicate 20 degrees, 40, 60, and a small circle here is at 80 degrees. Another new option under setup is the ability now to go into a high contrast screen mode. And that was requested by a couple users. That just makes it a little easier. Some of the colors I use in the normal mode can be hard to see. Not a lot of contrast. Then the major changes is going to be with JPL tracking. And so this was introduced a couple versions ago. There's a new tab here now that we can download by a specific JPL ID, and I'll show you in just a minute where that might come into play. But in the previous versions, we could only download what's called the major bodies, not the minor bodies, which includes comets and asteroids. But you can see now we have an option under the comets and asteroid tabs. We have a new option here that we could download JPL data for comets and asteroids. So I'm just going to download my orbital elements for the comets. So my comets and asteroids data is from another source. And if we look under the acknowledgements here, it's from the International Astronomical Union Minor Planet website. And I did that because we can get a little more information, readily get a little more information from them. So I'm going to take a look at comets with a magnitude greater than 12. And this comet comes up here. And I actually did image it the other night. But so from this screen, we could start tracking. So we're just doing a normal go to it. So the mount is going to slew to where it is right at that particular moment in time. And then we can see up here it's going to do sidereal rate tracking. So in other words, the stars we're going to track with the stars. The comet may be moving at a rate slightly different than sidereal. And so if we did a long exposure, the comet might blur a bit, but our stars will be tight. And if we do custom tracking, then the comet's going to be nice and crisp, and our stars might be streaked a little bit. However, in this case, well, we'll first download. So we're downloading JPL data, and what SkyTrack is doing is trying to match this database with the JPL database, and that works the majority of the time. So now we have the tracking data, and I'm going to click enable custom tracking rates, and now this says custom up here instead of sidereal rate. And you can see it's closing in on it. What the software does is it applies a slightly different rate to catch up to the object and to get it centered in the field of view. Another new feature in this version is we can actually see what custom rates are being applied. So these are rates that are being applied on top of sidereal rate, which in RA is 15.041 arc seconds per second. So you can see this is a very low value. So this object, this comet, isn't moving at a rate much different than sidereal. And if I go back here and take a look, we can see it's actually 2.2 astronomical units away from the Earth. An astronomical unit meaning the distance between the Sun and Earth. So it's a fair ways out there, and so that's why it's not varying a whole lot from our sidereal rate. In fact, we can calculate that out. So let's just calculate it out in RA. And if I pop up my calculator here, and let's say I was going to take a 2-minute exposure, so 120 seconds, then times this arc seconds per second, so 0.002293. So we can see in our 2-minute exposure, in RA anyway, it's only going to move 0.275 arc seconds. So right now the setup I have in my observatory, my image scale is 1.2 arc seconds per pixel. So this is only going to move like a fraction of a pixel. And in fact, I did image it the other night. And that's what I got. I think that was a 2-minute exposure. So we can see the comet is nice and crisp, and our stars are still fairly round. Now I should mention here, this was unguided, and I'm using a mount that has absolute encoders, so there's no periodic error. So I can get pretty good results with 2 minutes or more. Actually, with 10 minutes exposures, I can get good results at my image scale. So that was comets. Let's take a look at asteroids. Download the database. And I got a filter for a 16 magnitude or brighter, and just under 30,000 asteroids in the Jpl database. There's actually, I think, 1.5 million. So there's a lot of other objects in there. But this was one I was taking a look at. And again, we can salute to it right from this screen. And if we do that, our tracking rate is going to be at sidereal. But we can also, like in Comets, we can download now Jpl data for asteroids. And when I go in here, here it is here, I'm going to enable custom tracking rates. You can see it was almost a full arc minute already wandered from my center of my field. So it is moving a little quicker than what that comet was in relation to sidereal rate. And once this settles down, we'll look at these actual values of what it's at. And it's moving 3 times quicker in declination than RA. So let's just calculate that for a 2-minute exposure again. So 120 seconds times 14686. So we can see now in 2 minutes it's going to move, and this is just in declination, it's going to move 17.6 arc seconds. So if I divide that by my image scale, it's going to move almost 15 pixels. So if we wanted just a clear image of the asteroid, then we would definitely need custom tracking rates. If we do sidereal rate, we're going to get a streak. And I did take a couple images of this particular one. It's fairly dim at a magnitude of 15, but I was able to see it well with a 2-minute exposure. So there it is there, and the tracking rates worked very well. It's a nice crisp little dot of light, and you can see our streaks of stars. So now again, the other night the rate might have been a little different, but you know, this, according to what we calculated in a 2-minute exposure, this is at least 15 pixels wide. This is a really extreme crop. And then for interest, I took the another image about 5 minutes later, well, 5 minutes apart from the start of each image, and you can see here the difference. So there's these 3 star streaks here and here, and you can see it move from there to over there. That does verify that, yep, that is our asteroid, and it's moving through that star field. So again, depending what you want it to do, you might try taking images at sidereal rate, and then take a bunch of images, put them all together, and make like an animated video. So if we're tracking at sidereal rate, what we'll see is all the stars being still, and we'll see a little asteroid in our video moving across the star field. But if we tracked using the custom rates, what we'd see is the in our collection of images creating a video, we'd see the asteroid being still, and we'd see the stars streaking across that. And I'm actually going to try that if I ever get a clear night here again. We have a lot of clouds lately, so it's kind of fun. So that's the difference between the two. The other thing I want to show is, back to Comets, look at them all. I'm going to take this Shoemaker Comet, and we're going to download, and go back here and click on it, and then we get this highlighted message popping up saying that there were multiple matches found for that particular comet. And if I look at my data here, you can see that there's 3 different records, and I'm not sure what the difference is going to be in each of these records, but I usually select the most recent one. So I'm just going to copy the Jpl record ID, and then that's where we can use this new tab. Paste it in there, and now I can download that specific record. And before I had this message, and now when I select the one we just downloaded manually, now we have data. And like I mentioned before, the Jpl database has like 1.5 million or something different objects in it. And so you can go into the JPL Horizons website, you can search for objects, and you'll be able to see that JPL ID, and then you can go to this tab and manually download that particular one if something you were looking for you didn't have access to it through SkyTrack. But SkyTrack does display all the major bodies that are available in JPL, and as I mentioned in another video, once in a while you have to click this download updates, and you can just see that number changed from 496 or something to 511. So they're continually updating that. So it's Comet and Asteroids. You won't necessarily have access to everything in JPL, and that's where you could go into JPL, find that ID, and then do this download here. just want to show one other thing. And so these particular objects here, it calls them spacecraft. They're like a geostationary satellite. And I'm going to download it. So they're geostationary. That means in RA they're moving at about 15.041 arc seconds per second, which is sidereal rate time. So let's just see if that's right. So what we're going to do, we're going to click that, and we're going to go to that object using custom tracking rates. And so we're slewing right now. Once we get fairly close, the custom tracking rates will start, and then we'll see here what rates are being applied. So again, initially that's a fairly high rate because it's modifying the rate in order to center the object. So once this gets close to 0, we'll take a look at that rate. Okay, so there we're tracking rate. So you can see it's applying a minus 15 arc second per second. So in other words, it's counteracting the sidereal rate to keep the mount almost totally still, not perfectly still, because the geostationary is moving a little bit. But I thought that's pretty neat. You can see it work. So that rate is counteracting sidereal rate, and these rates are being applied on top of sidereal. So that's, I think, pretty well everything I wanted to cover. The other new features is delete all. So all these files are kept in a subfolder of the SkyTrack folder, and they're only good for 3 days, and then you have to download a new one, but the file's still sitting there. So over time you could accumulate a lot of files. So I put this delete all in. So if I click that and do that, it asks for confirmation. It deletes everything sitting in the folder there. So just a little cleanup option. Anyway, I hope this is useful. Since I added this Jpl custom tracking, I've had a lot of fun with it. I find it interesting, and doing videos like this of asteroids and such. And I do look forward to getting a clear night and see if I can do some kind of animation with that faint little asteroid moving through the star field. So I hope you find this useful, and thanks again, and I hope you enjoy it.